Hey guys, welcome back. We'll continue with the book Automate the Boring Stuff with Python. In this chapter we are going to cover how to manipulate images with Python. If you want to follow along for free, you can head over to automatetheboringstuff.com and access this chapter, or if you prefer a physical copy of the book, you'll find a link in the description down below. Now when we want to edit any graphics or images, we would typically use a dedicated graphics software such as Adobe Photoshop for instance. But if we want to edit or manipulate a lot of images at once, then a programmatic approach, for example by using Python, is a better idea. We are going to use Pillow, which is a third-party Python module for interacting with image files to copy, crop, resize and edit various images. And to follow along, you can actually download the images we are going to edit. The link is in the description down below. And on the linked page, you can then go to download the files used in the book. And this is going to download all the files that you need. And you can then go ahead and copy the sophie.png file over to your working directory. So that should be under users, your username, and then mu_code. And then we're going to make some changes to this image and use it to learn about how we can manipulate images using Python. Now before we actually start writing code, let's have a quick look at some basics of computer images and also about how colors are represented. So there are different ways to represent colors in code, but one popular way is to use RGBA values. And RGBA stands for red, green, blue and alpha. And alpha basically means the amount of transparency of the image. And then we can use values between 0 and 255 to specify which amount of red, green, blue and alpha is contained in a specific color. So for instance here the color white has equal amounts of red, green and blue, and it also has maximum transparency. If instead we are interested in the color red, we can see that the red component, the R, contains a maximum value, 255, while the amount of green and blue is set to 0. And again, alpha is set to 255 because we don't want to display a transparent color. Let's see how we can represent that in code. And we actually don't have to remember those RGBA values, but we can get them from code. And let's have a look at that. But before we do that, we first need to head over to the gear icon inside of our Mu code editor. And then we can head over to third-party packages. And here we need to make sure that we add Pillow to the list of packages and click on OK. And this is going to install the Pillow module for us. Once we've done that, we can open the REPL inside of our Mu code editor. And then in the first step, we need to make sure that we import the image color module from Pillow. And then we can use the getColor method on the image color module, and we can pass the value for which we want to display the RGBA values. And then as a second argument, we need to pass RGBA to specify that we want to display this in RGBA values. And then we can see the same value we saw before for the color red. So here red is set to the maximum amount. We don't have any green or blue. And again, transparency is set to the maximum amount as well. And we can use that getColor method to basically get any color. So for instance, if we're interested in the RGBA values for cornflower blue, we would pass that as a first argument, and then we get this RGBA value. So of course, blue is set to the highest value here, but we also have green and some red in here. So this is the representation of this particular color here. Now when we work with images, we need a way to represent the individual pixels and their coordinates. And to do that, we are going to set an X value and a Y value. And the top left side of our image always has the coordinates 0 and 0. So an X value of 0 and a Y value of 0. And then as we move over to the right, the value for the X coordinate increases. And as we go down, the value for the Y coordinate increases. So as an example here in this image on the bottom right side, we would have an X value of 27 and we would have a Y value of 26. And that's a very easy way to identify the individual pixels of an image we are working with. Now with those basics covered, let's actually look at how we can work with images using Pillow. And for that we have to import the image module from Pillow, and then we can go ahead and we can open an image. So here we are calling the open method on the image module, and we pass the name of the image that we want to open to it. So in this case, sophie.png, which is the image we downloaded before. And it's important that we move that image to our working directory, so to the Mu code directory, so we can actually access and open this. Now once we open that image, we can have a closer look at its attributes. So for instance, we can have a look at the size. So here we can see we have an x-coordinate of 816 and a y-coordinate, the height of 1088 pixels. And if we open up our image and we have a closer look, we can indeed see that the height of the image is larger than the width of the image. Now the width and height of the image are represented as a tuple here, and we can use those tuple values and associate them with individual variables if we wanted to. So for instance, we could say that the width and the height stored in the tuple should be saved in individual variables called width and height. And then of course we can simply address those variables to have a closer look at the image's width or height. We can also have a look at the file name of that image. So here we can see sophie.png, and we can also have a look at the format. So here we can see it's a PNG file. We can also use Pillow to save our image and to create a different file format from the file that we have. So in this case here we are storing that image under sophie.jpg, so we're effectively turning a PNG file into a JPEG file. We can also use Pillow to create new images. For that we would use the new method that we call on the image module, and first we need to pass the color mode that we want to use, so in this case RGBA. Then we need to pass the size of the image as a tuple, so the width and the height, and then we can specify a background color. So in this case we are setting the background to purple, so we are effectively creating a purple rectangle. And then in the third step we can go ahead and we can save that under a specified name. So in this case we are calling it purpleimage.png. And if we now switch over to our working directory under users username mu code, we can see there's a new entry purple image. And if we open that up, we can indeed see we have a purple image with a specified height and width. But we can not only create new images, but we can also edit existing images. And for instance, we can crop an image. We saw the Sophie cat image before, and we could, for example, just crop the cat's face here and save that as a separate file. And to do that, of course, we need to specify the various coordinates of the area that we want to crop. So here we would provide the pixel values of that rectangle here that we want to crop. Now switching over to the code editor, again we need to make sure that we import the image module from Pillow, and then we call the open method and we pass the name of the file that we want to open as an argument to that method. After that we can crop the image that we opened, and for that we are passing a tuple in here with the 4 values for the rectangle that we want to crop, and we are storing that back in a new variable, and then we can use that new variable to save our image under a specified name. So in this case we are calling it cropped.png, and this is not going to change the old image, but it's going to create a new image with a cropped section called cropped.png. And if we open up that image, we can see that indeed we cut out that face of the cat, and the existing image still exists, but this is a new cropped image that we created. We can also copy and paste images onto other images. For that we are going to open our image again, and then we're going to call copy on that image, and we are going to store it in the cat copy image variable. Now we can use the crop method to crop out the face of the cat as before, and we're going to store that in the face image variable. Using the paste method, we can now paste that cropped image to specific locations on the original image. So in this case we are going to use the tuple 00, meaning we're going to paste that image on the top left side of the original image. We are also going to paste that image at location 400, 500, so roughly in the middle of the page. And finally we can save this new image under pasted.png. Now if we open up that image, we can indeed see that we created a new image, pasted.png, which contains the original image, but then we pasted the cropped face of the cat to the top left corner and also to this location here. We can also resize an image using code. For that, again, we need to open the image we want to resize, and we need to extract the size, so the width and the height from that image. We are then calling the resize method on our image that we opened, and we are passing the new width and height to it. In this case, we are using the width and height of the original image, and we are dividing it by 2. And since the result might be a floating point number, we're then turning it into an integer value, because only integer values are accepted as pixel values. Now we can save this resized image under the name quartersize.png. And if you now compare the original image to the resized image, we can see that our resized image indeed is a lot smaller compared to the original image. Now, a common action performed on images is to rotate or flip images, and we can also do that using Pillow. So here again we are opening our sophie.png image, and then we are calling rotate on that image, and we are passing a value in degrees, so 90 degrees. So we are going to rotate that image by 90 degrees counterclockwise, and we are passing a value in degrees, so 90 degrees. So we are going to rotate that image by 90 degrees counterclockwise, and then we're using the save message to save this under the name rotated90.png. And if you open up that newly created image, we can see it indeed has been rotated by 90 degrees counterclockwise. Now we can even change the color of individual pixels. And for an example, let's create a new image using the new method. And we are going to create a new image that has a size of 100 and 100. Now we are specifying the color mode to be RGBA, but we did not provide any background color. Therefore, if we use the getPixel method and we want to get the color value of the pixel at position 0, 0, we get back this RGBA value, so we can see all values are set to 0. That means we basically have a transparent pixel, so nothing is displayed. It's basically a fully transparent image that we created. However, we can use a for loop to color multiple pixels at once. So in this case here, we are looping over the x and y coordinates of our image, so the width and the height. And for the width, we are going all the way from 0 to 100, so we are taking the complete width of the image. But for the height, we only go up to the value of 50. If we think back, we have a height of 100. That means we are only taking the top half of the image. And for those pixels in that range, we are setting the RGBA value to be 210. That is a light gray color. So the top half of our image now has a light gray color. Now we can also color the bottom half of our image. For that, we could take the same approach, or we can work with the image color module. And that allows us to provide the color name directly. So here we are using the getColor method, and we pass a value of dark gray to it rather than using the RGBA value directly. In this case, we are looping again over the entire width of the image, but for the height, we are only taking the bottom half of the image, so the height from pixel 50 all the way up to 100. And within that range, we are setting the color to be dark gray. Now, as a last step, of course, we need to save our image. We are going to call it putPixel.png. And if we open up that image, we can see that indeed the top half of our image is displayed in a light gray color and the bottom half is displayed in a dark gray color. Let's continue with the project. So let's say we have a lot of images, and it's our job to resize those images to a specific size and to add a small logo as a watermark to the corner of each logo. Now we could do that using a graphics program, and some applications such as Photoshop also have options for batch processing, but of course that software is proprietary and we might have to pay significant fees to get those. So instead we are going to use Python to accomplish that, and on a high level we are basically going to follow these steps. We are first going to load the logo image. The logo image is part of the resources that we downloaded before, so we still need to move that over to our folder. So specifically, we have to make sure that the cat logo is inside of our MuCode working directory. And a quick note, when you download that image, it's way too big. So I resized it to 90 × 86 pixels, which maintains a height to width ratio. And then we are going to loop over all the images in our working directory. We're going to check whether the images inside of that working directory are wider or taller than 300 pixels. And if they are, we're going to reduce the width or height to 300 pixels and then scale down the other dimension proportionally. And then we're going to post the logo to the bottom right corner of the image, and we're going to save that image into another folder. So let's take a look at the code, how we can accomplish that. We need to import both the OS module and also the image module from our Pillow module. Then we are going to specify the size of the images, the maximum size, which is 300 pixels. And we specify the logo file name, so that's the catlogo.png, which we downloaded. That's the logo we're going to add to each of those images. We are then going to open that logo image and we are storing it in the logo image variable, and we are also going to get the logo width and the logo height from the logo. Since we don't want to overwrite our existing images, we are going to use a make directory, which is part of the OS module, to create a new directory called with logo, and this is a directory where we're going to store all the modified images. Now once that's done, we're going to loop over all the files in our working directory. So here we are taking the list directory method and we are looping over all of the files, and we are checking if those files end in .png or JPEG, meaning whether those are images, and if they're not ending in either one of those names, then we're going to call continue, so we are going to skip over all the non-images in the working directory. Now for those images, we are going to open them and we are going to extract their width and height. Then we first need to check if the images need to be resized, so whether they have either a width or height larger than 300 pixels, which is what we check over here. And then if the width is greater than the height, we are going to set the width to 300 pixels and are adjusting the height accordingly. And in the opposite case, when the height is larger than the width, we're going to set the height to 300 pixels and downscaling the width accordingly. Now after that, we need to resize the image. So here we're going to resize the image, passing the width and height that we set as attributes to this call. And then the final step here is to add the logo. So here we are going to use the paste method. We are pasting the logo image and we're making sure that the logo is displayed on the bottom right side, which is why we are subtracting the logo width and the height from the width and height of the image itself. And that is necessary because, of course, the position 0, 0 is on the top left side of our image. So basically, when we subtract the width and height, we just get that position on the bottom right side where the logo should be placed. And at the end, of course, we are going to save those images. So we are storing it in our with logo directory, and this is where all the images will be stored. So with that being set up, let's run our program. And we can see that we are adding the logo here, we are resizing images, and we are storing it in the respective directory. Now if we have a look at our with logo directory which has been created, we can see our images now all have a logo on the bottom right side, which is the logo that we added. And also the size is adjusted, so our images are properly updated. Now we can also use our pillow module to draw on images. So for example, we could draw a line or a rectangle, for instance. To do that, we need to import image draw as a module and also the image module. We can then create a new image. As before, in this case, we are going to create an image with a dimension of 200 times 200 pixels, and we're going to set a white background. We are then passing that image that we created as an argument to the draw function, which is going to create a draw object for us. And now we can draw, for instance, a line by using the line method. And here we are specifying the different points where we are drawing the line through as tuples. And we are also specifying that this should be filled with a black color. We can also draw a rectangle, and in this case we're filling it with a blue color. And other forms are also possible. For instance, we could draw an ellipse, and our ellipse is going to be red. Now finally we can save our image. We are calling it drawing.png. And if we then open up that image, we can see we drew our objects here and they are displayed. So that's another way how we can basically create images and directly draw graphics objects onto an image. Now let's have a look at the practice questions. The first question is, what is an RGBA value? So the RGBA value is a tuple of 4 different integers, each in a value range from 0 to 255. And those letters correspond to the color red, the color green, the color blue, and the alpha, so the transparency. And using those values, we can specify the color, and RGBA is just one of several color modes that are typically being used. How can you get the RGBA value of cornflower blue from the pillow module? So for that, we would first import the image color module from pillow, and then we use the getColor method and we pass the name of the color, so in this case cornflower blue, as the first argument, and then the color mode RGBA as the second argument. And then we get back those RGBA values for that specific color. What is a box tuple? So a box tuple is a tuple value of 4 integers. We have the x coordinate on the left edge, then the y coordinate on the top edge, and also the width and the height. What function returns an image object for, say, an image file named sophie.png? So to accomplish that, we would use the open method on the image module, and we pass the image name, so in this case sophie.png, as an argument to that method. How can you find out the width and the height of an image object's image? So to accomplish that, we would use the size attribute, so we call size on our image object. And that is going to return a tuple with the width and the height value. And if we want to have the width and the height in separate variables, then we would specify width and height and then set that equal to the return value of calling size on our image object. What method would you call to get image object for an image with the dimensions of 100 pixels in width and 100 pixels in height, excluding the lower left quarter of it? So for that we would use the crop method, and we pass a tuple of 4 values to that method as an argument. After making changes to an image object, how could you save it as an image file? So to do that, we need to use the save method, which we call on the image object, and we pass the name under which we want to save this file as an argument to that method. What module contains Pillow's shape drawing code? So to draw on images, for example to draw lines or rectangles, we would use the image draw module, which is part of Pillow. Image objects do not have drawing methods. What kind of object does? How do you get this kind of object? So for that we need to create an image draw object, and those have some shape drawing methods such as line, point or rectangle or ellipse, and those are then returned by passing the image object to the draw function, which is part of the image draw module. In this video we covered how we can work with images, how we can edit images, resize images and also create our own images, and also how we can draw on images. In the next and final video of the series, we are going to cover how to control the keyboard and the mouse with automation techniques focusing on the graphical user interface. If you found this video helpful, please leave a like down below and feel free to subscribe to the channel. See you guys in the next video.